Hello, my name is Paul Bourgeois, and today I'll be doing my video presentation on anti-computer forensics. I will be focusing on three commonly used anti-computer forensic tools: steganography, encryption, and file wiping. First, I will be focusing on steganography. Steganography is taking documents or files and embedding them into an image. Now, to the human eye, the image doesn't look like it's been altered with or tampered, unless you use a document or a file that is bigger than the image size. So I will be using the software RSecret. This is a free software that I found online that is pretty nice actually. So I'm going to select a carrier file. I'm going to use a picture of my professor. Handsome, isn't he? And I want to embed a file. Okay. I'm going to do a pre-made file called, this is a test, it's a document. It's a Word document, so it's only not going to take up very much room. But let's say I didn't want to use a document, I just want to send a message embedded into an image. So I can add just a message, and put a little text in there. You'll never get it. Okay? So then now we just do a password, and password is going to be password. And so now we can save the steganography version of this picture. I'm going to save it as Dawn. Okay. So now in my demo file, I have Dawn Lewicki and Lewicki Dawn. So we are going to look at the hashes of the two images, so I can show you that they're completely different. We're going to add evidence item in FTK Imager. This is a really good program that we learned in class. We used in class and we learned about it. So we're going to go to demo. Okay, and you can see here, this is Dawn Lewicki. This is the image that I embedded the documents into, and this is the original. As you can see, the file size is almost twice as big than the original. I mean, to the human eye, I can't tell the difference unless you blew this image up. I feel like it'd be very pixelated and you still wouldn't be able to tell the difference. So what we're going to do is we're going to export the hash list of both of these. Desktop. And this exports it as an Excel document, which then shows you that the hashes are completely different. This is the image that has the information in it, and you can tell that it's completely different than the original. So a forensicator would see this if there were two pictures on there, and realize, hey, this is not right, and then run some diagnostic tool on it. I'm going to save this. Now let's say someone sent me a file or an image that has files embedded in it. So I go in here, I go unhide, select the image. We're just going to enter the password, unhide it, and now what we can do is I can double click and I can save the information. And there we're viewing the message. And I can even save it as a text. And then if I go in my demo folder, there's the two, there's the document and the message that I embedded in that picture. So steganography, very deadly when in anti-computer forensics. The next I will be focusing on is file wiping. File wiping is different than disk wiping. Disk wiping is taking your whole drive and throwing just random binary numbers, ones and zeros at the drive, overwriting it, so that way you can't recover data off of it. File wiping is just throwing binary, ones and zeros at a certain file, so that way it's wiping it from that part of the drive, so that way it's not recoverable. I will be using rwipe and clean, which is not free, but this is a demo of it, and I find this to be a very good program. You can see here that these are all the applications on the left-hand side that leave traces. These are all the applications and everything in the system. These are everything in a user. So if there were multiple users, there would be, you know, my user account, another user account, so on and so forth. And then you have my 3 internet browsers: Internet Explorer, Google Chrome, Firefox. Okay, so we can look at the history of Firefox. This is going to take a little while to load, and this actually pulls up the history, even if it's been deleted. It pulls it up, it recovers it, and there you can see all my history, and we can wipe that. You know, and it's great. You know, we can do cookies. It just shows up all my cookies from every site I've ever been to, and we can wipe those also. So, what I was very surprised is that there's Skype. I didn't know that Skype saves every received file, sent file, chat history, and call history. So you can see here that if I click on chat history, this is my chat history from day 1, dating back all the way back from, you know, when I first started using this over a year ago. This was, you know, it wasn't as new when I first got it, but it was new to me, and it just saves everything. So you can see here that this is the account. So if I had more than one account, it would show the different accounts, the date and time that we were talking, and the Skype name, and their display name, and then who the chat partner is. So it's just, you know, I think this is phenomenal. Like, you can see that, you know, Forensic Hacker could be like, well, you know, you were talking to this person on this date. And also, it saves all your received files. So if I received a file I shouldn't have received, and a Forensic Hacker was like, you received this file from, you know, this person at this time, this is the file name, and this is where it was saved to, you know, then even if I wipe that, let's say I wipe that file from my drive, they can say, well, it was here, we have proof of it, but you wiped it. You know, I'd be caught. So, you know, I'd have to wipe that also. And the coolest thing about this program is a schedule. You can create a schedule that every time you shut down, you shut down your computer or close a browser or Skype, it wipes all the information that you get from you know, all the traces from that program that you're using. I think that is huge. Very good programming on their part. Great feature of this program. If it was free, I would have it on my machine, but this is only a trial version. I have like 10 days left, so I will be uninstalling it, not paying for it. And finally, I'm going to be looking at encryption. You know, encryption is taking a file, using a special algorithm to encrypt it, and then you have to have the correct key to, you know, get to that file and view the contents of it. So layman's terms, you put a password on it, you have to have the password in order to get into it. So we're going to be looking at TrueCrypt. TrueCrypt, what it does is creates a container, and then the container, when you mount it, is mounted as a drive on your computer, so that way it's easier to access, and you have to have TrueCrypt installed on your machine in order to view the contents of the file or the container. So what we're going to do is we're just going to create a volume. We're going to create just a normal one, standard. So I'm just going to select this place to put it. So we're just going to use test. And now, the really cool thing about this is it has more than one encryption algorithm. It has AES, which is, you know, by the government, says it's never been cracked, Serpent, and Twofish. Now, the cool thing about this is you can use all 3 encryption algorithms on this container. What it does is, first it will encrypt it with AES, and then once it's encrypted with AES, it'll then encrypt it again. It'll put Twofish on top of that encryption, and then Serpent on top of that encryption. So that just makes it more deadly for forensic haters trying to crack it. And then we can, you know, do the volume size, and we'll just do 10 megs, so that way it doesn't take that long to create it. We'll do a password, display it, and this one is going to be password. Sorry about that. And it'll warn you, too short, not secure. That's okay. Now what this is doing is, as you can see, I'm moving my mouse and the random pool is just goes crazy. So this is randomly creating a hash algorithm, so that way it's just not the same hash algorithm for each time you create a new one. So that way forensicators can't be like, well, I'll look for this hash algorithm and you find like five files within one number or hash within each one. So this is randomly creating it every time, and there it's been successfully created. Okay, so we'll exit, and we will mount this real quick, and I will throw, this is just going to give me 2 errors, which don't mean anything. Display the password. Okay. See here, you can see it's mounted. That's the size of it, encryption, and the type is normal. I'll elaborate that in a little bit. So what we'll do is we'll start, computer, and there is my mounted TrueCrypt container. So we'll just click and drag and put that in there, just so we have something in there. Okay, so we're gonna dismount this, and what we're gonna do is TrueCrypt can allow you to create a hidden TrueCrypt volume. So in normal mode, it would first create a TrueCrypt container and then create a hidden volume. What we're gonna do is the direct mode. We're gonna create a hidden volume inside of an already pre-existing container. So we're gonna select the file of the pre-existing container, which is test. Okay. And then it's going to ask me for the password of the pre-existing one. So you just can't just go in and get a pre-created container and just put your own hidden one on it. So we'll do that. It's saying it's correct. So now we're going to put our hidden one in, and we're going to use all 3 of these. So that way we know that no one's going to get into this. We're going to make it 5. And the password is going to be different. And okay. Now we're going to use key files. What a key file is, it is a certain file that has to be in a certain place when referencing, when typing in the password. So it's going to look at the password password's correct, then it's going to look to find a key file in a certain place on, it could be, a flash drive, an external drive, or it could just be on your computer. So we're just going to add a key file. What we're going to do is we're going to use the XML hash text. So that way, we can add that. Okay. So that is going to be the key file that has to be referenced. Now, if that is not there, or has been deleted, or it's been moved, let's say I move that to, my document, and I try to reference it, it's going to say, no, this is not the correct one, it won't accept it. So what this is doing is creating a digital thumbprint of that file, and it's going to look for that, make sure it's exact, and then it'll allow it. So we're going to mount this. Just give those 2 errors, no problem. I'm going to use key files. Now I already have a key file registered, and this is just a decoy, thinking that, oh, there's already a key file registered, that is the key file. No, that's not the key file. As you can see, that's test document, not the hash text Excel file that I use for my hidden partition. So we'll do that. Okay, display password. Okay, and there you go, hidden. It shows hidden, and the 3 encryption algorithms. We'll go in here, computer, and there it is. This is my hidden one. I can then put anything that I really don't want anybody to find in there. Most people, when they get a password, they think, oh, that's it. Well, TrueCrypt, no, that's not it. You get a password, it could be not the hidden password, it could be the one that's a decoy that you think you have all the information, but it's not. Now, the downfall with key files is they can be stolen, corrupt, or deleted. Once that happens, there's no getting them back. I could make another hash text Excel file exactly the same, but it won't have the same hash, it won't have the same fingerprint, so that is the only downfall of key files. I hope you enjoyed my presentation on anti-computer forensics.